Well, good morning, everybody. Right now, today, as our jet stream winds are screaming across parts of North America, it is one of the best setups that we could ask for to develop low pressure. And I want to just spend a second on this animation to kind of show you what I'm talking about. Let's talk about how things got set up. We started to push ridges of warmer air finally into parts of Alaska, up into the Arctic, also here into the North Atlantic, into Greenland. What is that doing? That's allowing for the flow to start to empty out of the northern latitudes into the southern latitudes. That's going to be the delivery of our colder air. Now, it's the contrast between the warm and cold air that eventually sets up what we call a thermal wind gradient. That is where the atmosphere is more compacted over where it's cold, much more expanded over where it's warm, and the net effect of that is to increase something called a pressure gradient force. Now, the pressure gradient is what drives the wind, and where it's strongest is where you're going to have your fastest winds, and that is where the jet stream tracks. So it comes out of parts of the Pacific here, it splits up several times, but then it builds into 1, 2, and 3 deep troughs. Now, what are the significance of those troughs? We call them troughs of low pressure because on their inside they have very cold air that is dense and it is therefore compacted. On their southern side, they have a much more less compacted air, so spread out. It's warm, it's less dense, and the contrast is what drives these winds again. Now, what's fun about this is there's a subtropical component to the jet stream here, and there's a polar branch of the jet stream there. And what happens is, as this flow comes across North America and hits the western mountains first, once it leaves the mountains, so let's just kind of find very quickly here kind of the spine of the Rockies, it then descends the plains, and you end up getting this stretching effect in the atmosphere. So you have a few things working for you here. There is spin, cyclonic spin, simply due to the curvature in the flow. There's also cyclonic spin because the speed is fast here and slow there. So you can see how that's going to spin things up in that direction. And then you have the stretching as the flow comes off the mountains, which takes this and tightens it up. The net effect of all of that is just to suck the air out of a column right here, producing low pressure. The atmosphere in response down at the surface tries to fill it in. And so it's just constantly trying to undo the fact that the upper levels of the atmosphere are taking air out at a greater rate than the lower levels of the atmosphere are putting it in. And that's happening here. It's also happening there, and it's also happening here. And those are the three main troughs that I can just analyze for you for this moment here. But let me just show you. Let's go down to the surface and see it. So what do we end up getting? There is 1, 2, and 3 deep low pressure systems. That's not to ignore others, but this is going to be the one I'll be watching most carefully today. Now, you can also see this by looking at water vapor imagery. So what we're looking at here is upper level water vapor imagery, and wherever we see the bright colors and through here, this is where moisture is being put. It's rising in the atmosphere, so it's going up and up and up, and we're measuring that infrared temperature of it, and you can just see these huge plumes of moisture exploding. So there's almost a 3D effect of this. Air on the backside is coming down and descending, coming right in through here. Watch it. See the dark area here? That's descending air. See it? And then ahead of it, we have all of the ascending air coming out like this, producing this big plume of moisture that's rolling out ahead of this next system. And as it goes forward, we're just going to continue to drop pressure ahead of the trough and fill it in on the backside. That's why high pressure cells always follow low pressure cells in this kind of daisy chain around North America. In fact, it's around the world. So the pressure is always decreasing out ahead of it, filling in the middle, neutral or pivoting in the middle, and then filling in on the backside. The net effect is this, though. I mean, we just get right down to brass tacks here. It's this map that I told you is going to be colorful this week. What do we got going on here? Well, you can match up the colors and pause this, or just go to ag-wx.com and look at it if you want. It's in the top second row on this site. But this is all wind, flooding. We've got winter storm watches across many areas. Here. We have blizzard warnings that are in the Cascades, winter storm warnings to the south of that, freeze warnings on the backside, and then here's the major blizzard warning coming out of New Mexico and Colorado, hitting the panhandles, getting into Kansas and Nebraska. And all of this out ahead of it here, this is all winter storm warning. And what's been difficult about this system is being able to predict exactly where that rain-snow line is going to be and what the liquid-to-snow ratios are going to be as well. I've talked a lot about that over the last several videos. That is not to ignore what's going to be happening in the south and in the southeast over the next 2 days with respect to severe weather. But thinking on the snowy side of this first, I just want to show you something. I made this map yesterday when I got home of the days since the last blizzard warning was issued by a National Weather Service office. And what was amazing about this and why I made it was because we were concerned that parts of the Cascades were going to get a blizzard issuance by the Seattle National Weather Service office, because it had been 4,038 days up until yesterday morning since they had released a blizzard warning out of the National Weather Service at Seattle. That's 11 years. And here's the newest map. And now all of these zeros indicate National Weather Service offices, and you can kind of see their outlines here that have now issued a blizzard warning in the last 24 hours. So we expect to see this to be an extremely potent system. And I'm just going to tell you something. If you're on social media and you're not following like the National Weather Service for your local area or the National Weather Predictions Center, if you're not following any of those, you're kind of doing yourself a disservice. This is their key messages just for the next 3 days. You can see blizzard conditions, extremely heavy snow, which this track has moved in the last couple of days to be much more of a northwest trend on the heaviest snows. If you remember, it was originally going to hammer this section of the country. Well, we talked about that northwest trend being favored in the forecast unless you have antecedent cold air. Remember that. Cold air ahead of these does not allow them to translate north and west in the forecast trend. But we haven't had that. It's been mild in this area, so that's why we've seen that northwest trend. That's part of it. And then you can see down here the risk of very heavy rainfall. We're going to add to that the risk of severe weather as well. So I love this stuff. This is exactly what I want our National Weather Service doing. Here's another thing that's going to change. This is our season-to-date percent of normal snowfall. It's going to change from the Cascades in the Sierra Nevada to the Central Rockies through much of the Midwest, getting eventually here into parts with the next couple systems into sections of the Mid-South. And then, of course, we did see some bigger snows that hit New England over the weekend, but that just brought these numbers back up to these values. Instead of being zeros, we finally got some snow in this area. And I just want to let you know, this is also going to change. This is your last 30 days looking at temperature anomalies, average temperature anomalies. So the previous month, going back to the 8th of December, we can see just how warm parts of North America have been. Well, this is what the next 5 days looks like according to the GFS ensemble. This is day 5 through 10. This is going to be very important to watch the southern extent of this Arctic air because it will be over 20 degrees cooler than average for a 5-day stretch right into this area. And the worry is how far into the Gulf Coast into southern Florida this will make it. This is one of those really, really cold outbreaks. This is the iguana freezing in tree type things getting down here into Florida. By day 10 through 15, we're going to watch some moderation in the pattern as the Pacific jet extends and starts to flood parts of the southwest with very mild air. But we'll need to see how long we can get this colder air to hang on, and if it does fade a little bit once we get past the middle of the month, when does it start to return? Now, as I showed you earlier, it's all about upper level flow, and I want to give you just a flavor of that before I walk through the models here. We're going to begin with the ECMWF ensemble. So this is it. There's that deep trough. And what's making all of this pattern happen, what's really allowing for these deep troughs just to roll through, remember how we talked about doing this trajectory, is the very warm air that's building up in the North Pacific into Alaska and into the Arctic. And then on the Greenland side of things or the North Atlantic side of things, there's that same push. So that cold air had to go somewhere, and it's just diving in across the country like this, setting us up with that stronger temperature gradient, stronger thermal wind relationship, stronger winds, and an active jet stream. And that's just through Thursday. We're going to watch another shortwave click through here on Friday. Look at that guy there. Followed by another one coming down the spine of the Rockies here on Saturday into Sunday, reinforcing this, which means watch out for another system to take a farther to the south track this weekend because of the cold air that will already be in place. That's that antecedent cold air, okay? And then we're going to pay attention to this pattern out past the 16th, 17th, and 18th. Why? We just keep this kind of bridge of high pressure, higher heights. So the troughs just keep kicking around all throughout much of the northern hemisphere because of that. Now that takes you out 10 days, and we'll come back to this in a few moments. But remember, I do need to show you what we got over the weekend. Now the bigger snow events were in the Cascades, some pockets of the Rockies, and along the Sierra Nevada, and then into parts of New England. Now that rain snow line right in through here, we talked about being such a challenge to forecast. To be honest, I think the models did a good job with it. I mean, to be off by just a few miles, while that impacts tens of millions of people here, that's a win for the forecast models. But deep into the interior parts of Pennsylvania, New York, Massachusetts, much of New England here, as you can see, saw 6 to 12 inches of snow, some places even higher than that. We did have another system that came out, of course, that hit the midsection of the country, delivering some snow right here into the Midwest after going through parts of Kansas, and then on the northern side of this, some snow in parts of Minnesota and Wisconsin. But just take a look at the rainfall, because we've been wanting corrective action on the drought in the Mid-South, in pockets of the Southeast, and there's going to continue to be a lot of that going forward, including a severe weather threat in that area as well. So to kind of synoptically put this under a wind forecast before I give you the thunderstorm wind forecast, take a look. When that pressure drops so rapidly and the atmosphere tries to reach equilibrium by filling it back in, it's going to do so at a pretty violent rate. You're going to see winds coming out of this blizzard-prone area right in through here. They're going to easily be, synoptically, that's large scale, 30 to 60 miles an hour, locally even faster. That's through Wednesday. Getting into Thursday and Friday, as this system rolls up the East Coast, expect very, very strong winds, sometimes gusting. That's why they've got the big area of wind watch, okay? But that's why we've got some of these winds gusting here 50, 60 miles an hour. Now, the Northwest, this is where the strongest winds will probably be, just off of our coast, with wind gusts here getting 60, 70, 80 miles an hour. And you can see over on the East Coast, we'll see something similar. But with such an active pattern, we're not going to be slowing down these winds anytime soon. So as that cold air comes in, it's on the nose of very, very strong winds. So please be prepared for this as well. Severe weather side of it, this is where the Storm Prediction Center has got its day one. That's today, convective outlook for the 8th of January. And they've increased this area of enhanced risk along the Gulf Coast. So what's going to happen is a strong front's going to rip through here. There's going to be a tremendous amount of wind shear, plenty of instability, but the forcing will be strong to be able to create a pretty powerful setup down here for the outbreak of severe weather. If we flip this over now to day 2, getting into the 9th, this is going to stretch from basically this part of Florida all the way up to North Carolina for the risk of severe storms. And finally, we're at the models. So let's just show you what I've got here. High-res NAM first, 6Z run. Let's park it out there about 9 a.m. We're already watching some of the showers and storms open up here. The most challenging part of this forecast is to be able to define where that rain snow line is going to be today. We will literally be watching it now, casting it with radar observations, surface observations, to see as we play through midday where that rain snow line is going to be. But strong winds on the backside have warranted the blizzard warning. There could be some mixed precipitation between the snow and the rain, but severe weather tonight, you can already see the storms out ahead of it, the main front coming in behind it, 3 o'clock through, I'll stop it there at 11. So watch very carefully. Now overnight tonight, if you just kind of watch this area here, that rain snow line as defined by the NAM model will be very challenging and move around a lot. There will be a lot of places right along this area I just drew that are going to start off snow, then flip over to rain, then maybe go back to snow, and the 10-to-1 ratios are not going to work. There could be some ice out ahead of this as well, as we get a bit of a temperature inversion on the nose of that moisture plume coming into this area. But there's no doubt that there's been a northwest shift in the track of the heaviest snows, and you can kind of see it kind of encapsulated there by the time we get into early Tuesday morning. Now, I actually got to head from Champaign to Iowa tomorrow, so I should just put up my phone on the front of the truck and just kind of videotape the whole thing so I can remember how rough of a go this is going to be. But this is going to be some heavy snows and some strong winds on the backside of this. Now, did you notice some places get snow overnight tonight, flip back over to rain by the time we get into early tomorrow morning? And then as the front to the south of this rips through parts of the southeast and gets over here from Florida up to the Carolinas, tomorrow afternoon on Tuesday, we have the risk of those strong to severe storms. Now we're going to put some rain down on top of where that snow had just fallen here because of the trajectory of this low. So it's going to be really a mess up here in parts of New England. But the first round of cold air comes in behind this, such that by Tuesday afternoon and evening, getting into the overnight hours, we're going to get snow in this part of the Midwest. Now remember, that's just one system. That one finally exits, taking its snow showers with it by midday Wednesday. But the next one's already coming in behind it. And that one, just to show you here, begins with this lashing of this front here, which is going to push those snow levels up a bit higher in the Cascades, but it's going to add quite a bit of snow there. and also the very strong winds and the risk of that blizzard continuing at elevation. Could get some light snow coming out of parts of Montana, but some convective snowbursts, it looks like in the models here, running up over the mountains here in the northern Rockies, including a big section of Idaho's mountains. So that's it. That's what we're watching here in the very, very near term. Now, next we're going to flip over to the comparison between the GFS and the European. And at the end of last week, I talked about how the model performance had really dropped off. Well, we've now seen better initialization lately, taking it back up to where we were in December with both the European model and the GFS making a nice recovery. So let's see what they say. On the left, GFS, on the right, European. We've already watched with the high-res NAM out through Monday, into Tuesday, and eventually into Wednesday morning, Wednesday afternoon, and evening. Now, that is system number 1 rolling through. The next system then starts to show up here by Thursday, coming right out in the panhandles again. Now remember, there's going to be some snow on the ground here, and there's going to be some colder air that came in behind this low, so that cold air came in like this. So what we expect that to do is to push the next low pressure system a bit farther to the south. And you can see that as it comes out of the panhandles and rolls right into, somewhere between St. Louis and Paducah by Friday, this is going to have a better chance at delivering more snow farther to the south. So this is Friday night. Another potential, I'll be honest with you, I think the winds will be strong enough that they will likely not only issue a winter storm warning, but the risk for blizzard will be in here with the wind speeds getting up as high as they are. And that low curls through by Saturday. There's Saturday midday, getting into the weekend. So on the back side of this, very strong winds. On the south side of this, another 2-day severe weather threat, Friday into Saturday. And then we're going to watch this, really, I should just say it's Thursday night here, getting into Friday. Let me get the timing right on that. Thursday night into Friday from the south into the southeast. Snow on the backside, extremely windy conditions wrapping up around this. And then don't forget, we have our next system coming into the west already by Sunday. So here it is on Saturday into Sunday. As we just keep playing this out, I'm not even out a week yet. We have our third system showing up down here. That's the GFS solution. This is the European. Now you keep hearing me harp on and on about antecedent cold air. Remember, each one of these systems is taken a little bit farther to the south track. And this next one is down here. Why? The snow is helping push the storm track farther to the south. So is the cold air that's coming in behind this. So now what I'm getting concerned about, and I'll have to watch this trend all week, is this risk next week of getting ice in a couple of places right in through here. So you can see that in these kind of pinks or whatever that I use on my maps. This is next Monday into Tuesday of next week. So 3 storm systems, each one shifting farther to the south. The models have all 3 of them together. They're not exactly perfectly timed and put in the same spot by the early week system next week. But there's your next 3. So that would be the 5 in total we talked about coming at the beginning of this month. We've already had 2. Here comes the next 3. All right, total precip, high-res European model first. That's through Wednesday into Thursday. Here comes the weekend system adding to it. Let's park it out there 7 days. European model, high probability of 3, 4, 5 inches of rain down here. Very, high risk of severe weather, in my opinion, down along the Gulf Coast today, tomorrow here up the East Coast, up parts of the Southeast Coast, and then another round of just heavy rain. So this is the GFS solution. And let's just take it out there a week and compare the two. European, GFS. Biggest difference, in my opinion, is likely going to be in California because the European dips this next low farther into Northern California than the GFS does. I'm going to give you the national view on snow. All right, so this is your 7-day outlook for total snowfall from the European model. So there's 2 systems that are being combined here. We don't have the third system in this yet. Okay, this is the next 2 systems. We've watched the northwest shift of this heavy snow track. Remember, on my maps, you get 4 inches at the first shade of blue. So we're looking right in through this corridor from the next 2 systems of the heaviest snow. Of course, 4 to 5 feet possible in the in the Cascades. Good snows in the in the Rockies as well. Maybe some snow getting all the way down here to the northern panhandle of Texas. That's the European solution. This is the GFS. So look at the difference here. European GFS. The GFS is a little bit farther to the south, so parts of Missouri, Illinois, Indiana getting more of the snow than in the European model forecast. Just as a reminder, the ICON model, I showed you that last week, is very much aligned with the European solution at this point. But that is your next 7 days of total accumulated snow when you just kind of look at these systems in combination. The West needs this in a big way. This is the latest snow water equivalent map, so if you melt it all down, how much liquid do you have? We need these big snows coming into the West over the next 2 weeks. And the shift southward in the jet stream in week 2 is going to be critical for California's Sierra Nevada mountains as well. So from here, let's now go have a look at that ice thread. I just want to bring this up because out there early next week, I just want to be watching very carefully this corridor for the risk of ice. I'll just leave it at that, and we'll talk more about it throughout the week as we go forward. All right, finally, this is where we need to land. What do our probability maps look like? Let's take you back here to 10-day outlooks. There we go. So liquid equivalent side first, probability of 1 inch of liquid. Some of this will be snow, but if you melt it all down, what do you have? So notice some of that snow's got well more than 1 inch of liquid in it here. The heaviest precipitation threat is farther to the south, right in through that corridor. This is where we have the risk of 90% or better of 2 inches of rain. This is the 4-inch plot. So it's here and the northwest. And actually, if you step it up to 8, it's only the northwest. Now that, of course, being the liquid side of this, I do want to show you who's going to be drier. So let's look at the probability of less than 1/2 inch. It's pockets of the Canadian Prairie, the very northern plains, and the southwest. It's that same story. The flow's coming in like that. And that's why we tend to miss these areas farther to the north and over the southwest. From here, let's go talk about, no. I want to do one other thing. Winter probabilities. There we go. And chance of 3 inches of snow in the next 10 days. That's just a bright red map. There's the chance of 6 inches. You notice that in through this corridor in the next 10 days, we have a better than 90% chance of getting 6 inches of snow. Now, this is common in the West, but this is the track I'm watching most carefully. 12 inches of snow, according to the European model. We have some places in here that have better than a 90% chance of a foot of snow, according to the European ensemble. And 18. So the idea here is that there will likely be a spot in through this corridor here that could pick up more than a foot of snow out of this next system. And what is going to be challenging is that these models are made on the 10-to-1 snow ratio line. 10-to-1 snow ratio. That may not be valid. In other words, I think the snow ratios are smaller than that, maybe at times as low as 6-to-1. But that's okay. There's still a lot of moisture in this to make those big snowfall amounts. And let's go up to 24 inches just for the fun of it. How about 36 inches? This is just the Cascades. There's 48 inches. I mean, huge snows. And when does California get into this? Well, it shows up about day 10. You're going to notice day 10 out there to the 20th, the 21st, 22nd. We end up getting another jet extension. It hits California, rolls across the south, and exits. There is a problem with this flow. Okay, the problem is you end up getting back into this regime again. Remember me drawing that a lot back in December? If you get into that regime of flow, this is going to put drier air back into this area while California gets it, and the south gets it, and the East Coast gets it. And that's why the week 2 forecast, there it is, starting to show up with drier air in all the models. Now, California's staying wet. I don't know why the GFS doesn't pick up on this, but California's risk of staying wet is there. Same thing for parts of the Pacific Northwest, even getting out into the Rockies here. But other than that, it'll be to the south of it where I expect the wettest conditions to kind of roll through on that subtropical jet stream flow. Okay, temperatures. I got so much long-range stuff in South America to talk about. So here's Monday's highs getting into Tuesday. Look at the severe weather setup here with all that mild air, unstable air flooding into the southeast. There's Wednesday's highs getting into Thursday. And the really cold air arrives late Thursday into Friday and Saturday. I mean, look at this. We're going to have temperatures here that to start the week in the 40s for highs. To finish the week, we're going to have -8 for a high. So there's going to be more than a 60-degree swing in temperatures here when you include the lows. And as we get into the weekend, there's Saturday into Sunday, very cold air invading the central part of the United States with only Texas hanging on to some mild conditions. I just want to compliment the GFS forecast I showed you earlier with this 5-day sliding window of average temperature anomalies through January 18th. That's day 5 through 10, and then getting this all the way out there to the 23rd, day 10 through 15. Remember, as the Pacific jet extends, more mild air begins to flood in. How long does this colder air last? It all depends on the depth of the cold air that's still in place in the western side of Canada. Is the polar vortex helping out? Well, it is displaced. There's a large ridge pushing into Alaska. Now, this is in the stratosphere. It's kind of displaced our polar vortex here. But the tropospheric troughs are in this area, which means this doesn't line up very well to give us that just brutally cold, long duration, risk of colder air. Okay, I want to show you a couple of things the government has released. This is just kind of their outlook for drought through spring. And what's interesting about this is going to be a question as to whether or not El Nino wins or if other factors win. Now, if El Nino dominates, this whole kind of southern tier of the U.S. is going to see drought improvement, and even this part of New Mexico getting into Texas. We would leave the Mid-South drier. We leave the Rocky Mountains here a bit drier. But I want to make a case that I think there's more to this pattern than El Nino. Now, right now, you could say that the mid-January to mid-February outlook, which goes drier here, drier there, and a big section here drier. This has got El Nino signature written all over it. Subtropical jet comes in, stays south like this. The polar jet goes over the top and dives. And you know that northwest flow, no good in winter, which is why this area shows up drier. What I'm questioning is, are the models too biased to El Nino at this point? Now, I'll give them credit. I'm not taking that away from them, but I'm just questioning if they're too biased toward El Nino moving into mid-February. And here's part of my reasoning for that. We see that the MJO position over the next 15 days sweeps back around toward phase 2. Part of it probably comes out here toward phase 8. Now, I know the phase diagram doesn't show this, but I'm looking at velocity potential. That's really been my clue on where the MJO position is going to be. And if we go back into phase 2 or phase 8, well, phase 2 in January drops troughs in here. And that does not make dry conditions in the Mid-South, especially if you get ridging that runs up toward, the Canadian Maritimes. There's everything about this pattern that says from now through February, just expect it to have episodes of active weather. And if it goes over to phase 8, there's not much difference in that. So that's one piece of evidence, I think, working against this drier forecast here and also in the Northwest. I think it's much more active than being alluded to by the models between mid-January and mid-February. But if El Nino, which has peaked, continues to have its say, then you would go back to that forecast. But El Nino's not really had its full say across North America. I think part of that's because of the cooler water here and here. And I'm going to tell you something. We have got to watch this very carefully. This is our negative PDO signal and our negative PMM signal. And just thinking about that, I want to show you something. If El Nino peaks, and fades as quickly as the CFSV2 model, that's a U.S. model, suggests, and we get into, La Nina territory with a negative PDO signal that builds. In other words, if this water cools off and this stays cold, there's significant summer drought risk in the central part of the United States. But if El Nino fades more approximately, or more closely to what the European says, then there's going to be competition that's not only going to continue this winter, but it's going to continue all the way till next summer. And I just want to show you something for the winter side of this. If you look at the precipitation January through March, correlating it to El Nino, everywhere that's in the red colors represents wetter. So California, the plains, the south, the southeast, we're drier in the Mid-South, drier in the Northern Rockies, drier in the Cascades. And that's where you see the models trying to take things over the next 6 weeks, right? But what about the other parts of this flow? And I'm just going to pick on one of them, and that's the PDO. You see the Pacific Decadal Oscillation is very negative. It's been negative for a while. And if it stays negative and becomes a player for this winter, in other words, at times it has more of a say, well, this is what you end up getting. Let's flip this over to PDO and see what it says. There it is. And we're going to go January through March. Now, the PDO is currently negative. So what you have to do here is if we're looking at a correlation with precipitation, if it was positive, where it's red would be wet. But the PDO is negative, which means where it's blue, it's wet. So that says active here, active northern tier of the United States, active into the Pacific Northwest, and then drier risks at times. This is what I'm going to tell you. I think because these two features are going to compete, Some are going to win for a 2 to 3 week strand of days, and then the other's going to win. So this winter is going to be volatile because of the competition in the Pacific. And I like that. I like the fact that it's not stuck in one way. I like the fact that the PDO is going to compete with this. And don't forget, the MJO is going to run over the top of all of it. Now, when I say that competition's in place, one of the fears I have is that the forecast models are not going to be able to handle it. Because currently the January, February, March outlook from the European says drier, drier, drier. That's El Nino signature written all over this. Wetter, wetter, and really wet. But as we go forward, February, March, and April, I showed you this on Friday, drier in the west? Where? I mean, if the Pacific stays as active as it is, why would this go over drier? We'd see active systems rolling across the country, really tightening up that March, April, May time frame. I'm very concerned about very tight windows this spring based upon some of this information we're presenting here. This is now April, May, June. And as I mentioned last week, I'm getting concerned that as we get towards summer of two things, kind of an east versus west dry line here. Okay, not talking about the dry line for thunderstorms, but just a line that delineates where we expect wetter conditions in spring and early summer versus dry. And then later, what does it do across the south? Now I want to compare that to what was released yesterday from the NMME. Notice this is the February, March, April outlook. It's giving you a classic El Nino setup. Drier here, active, active. What about getting into March, April, May? It's trying to build its driest conditions out of the south, leaving much wetter conditions all around that. This is now April, May, June, and then May, June, July. And it's expanding this large area here of drier conditions into the central United States. In fact, look at this. That's June, July, August. Now you're going to look at this and go, holy cow, we're in for it. These models, they are the best we have, but they are inadequate. And I'm telling you that competition, this is the competition you have to watch. The cooler water to the north and how quickly El Nino fades. I'll watch it. I'll tell you about it. So when you look at this, you need to know that I am here. So don't look at this and go, holy cow, we're going to get in big trouble for next spring, next summer. No, I am concerned about very tight planting windows everywhere east of the Rockies, but I am not right now overly worried about a massive expansion of drought. So that's a lot, but that's where we are. How about looking at South America? I made this morning showing you the last 7 days, so the first 7 days actually of January's total precip. And I want you to see that down here is this 100 millimeter to 200 millimeters. So this is 4, this color's 4 all the way to 8 inches. So we've had some very, very wet conditions getting on top of where it had been very dry, while southern Brazil has missed out on some of this. We saw last, let's see, when was that? Was it Saturday? Shoot, I'll have to go back and look. Massive storm blew up over Cordoba, and Cordoba was kind of the last holdout for drought in Argentina, and they just received, I mean, look at this, some satellite compared to rain gauge estimates. We're talking about places that saw massive flooding at 8 to 10 inches of rainfall. Now, what's important about this, is that those first few days of January have really brought in some drought relief into a place that has been extremely dry for the last 2 months or 3 months. We've talked extensively about that. So what I'm going to do in these last couple of slides is show you this. This is the newest data I have for most of Argentina's growing areas on NDVI, well above trend. Let's go from there to southern Brazil. So from Mato Grosso do Sul down to Rio Grande do Sul. And their NDVI values have dropped off from being a peak at the end of December back toward average, and this is the line comparing to a year ago. So by the way, just looking at this, a year ago in Argentina, lowest in the last 20 years, that was the drought. Going farther to the north, from Rondônia over toward Mato Grosso, eventually finishing over here in Bahia, including Tocantins, Goiás, and Minas Gerais. This is the area that's in that lowest, 25% of the distribution of NDVI values, and this is where we're worried about the greatest stress. Now, over the next 7 days, we saw more storms coming through here and in Argentina. But looking at week 2, there's a drier signal as the MJO moves around, okay? Now, that drier signal will only be here unless the MJO truly gets into like phase 8. And if it does, it'll go back wetter in this area. But the model's been pretty consistent with this drier tongue here. And I'm just going to show you why very quickly. You'll notice here, that over the next 10 days, look at this coming in, that's going to be pushing, drier air into this spot. Now, can we get following that? This would be week 3, better chances for moisture. It appears that we can, because at the end of this month, we're starting to see the models put back in wetter conditions here. And to be honest, this is very ill-timed. This is when we will be full swing with harvest in this region, and wetter conditions in this area will actually be a detriment to the crop, not something that is going to be helping it out. It's going to continue to delay things further. This may make U.S. export markets much more critical going into this time frame. If there's any delays due to really wet weather out this far, we're going to have to talk about it. Okay, been going on for a while here, but there's so much to discuss. Hope you found this useful. Talk to you again in the morning. Thanks.